and them catching the people who have done it or have tried to do it. So yeah, that's another place you can get nuclear weapons from, and the forensic analyst would have to find out where did they get this bomb from? Where did it come from? How do we stop this from happening again? Often they use trace elements in the sample to find where it came from. A different mined uranium, for example, has different trace elements in it. Also, they examine the containers used to transport the thing. Whatever. I mean, nobody wants to hold uranium, in their hands. They're certainly going to use shielded. Usually not enough. Enough for the people who know what they're doing, but for thieves, usually not enough. But anyway, they're in containers, and we want to know what those containers are. Were the containers used in the mining? Well, we know they stole them from the mining area. The milling containers, were they used when they do the milling or the processing? Well, we know what the containers are. We can find out where they stole them from. Even the waste containers, maybe. Well, they got them from the nuclear waste area. Usually, they do not take it out of the original container because those were made specifically to help protect a person who needs to transport it. And they use the hairs, fingerprints. These are called root materials. If they find, let's say, pollen on the container, they say, aha, this must have been transported through or came from a field that had, let's say, clover pollen. So they know where it came from. Or the soil. It's a certain kind of dirt is found at the bottom. It must have come from a certain place. These are called root materials. So they're right now attempting to have a database of all the nuclear plants, processes, and the fuel materials, so that if they ever find it later where it shouldn't be, they'll know where it came from. So they're attempting to find this. Anyway, this is nuclear forensics. Generally not encountered in an ordinary police department. There's also evidence that comes from paint. Paint is everywhere. Just look around, you'll see paint on the walls of the room. Cars have paint. In fact, this is the most common paint evidence. It comes from car accidents. Also in burglaries, tools that like a crowbar that was used to pry open a window can have some paint on it that's scraped against, let's say, the side of the window. Very often, things pick up paint, and we want to be able to trace the paint at the crime scene to the paint that you may find on the suspect. Or you may, whatever. That's how it. Or you find it on a suspect, and we say, "Hey, wait, that's the same paint as was in the crime scene." So we can connect the suspect to the crime scene. Paint consists of pigment that gives it the color, and binders. That's the thing that makes it stick to whatever it's painted to. Okay, so you need both. I mean, you can have pigments without binders. That's just like it's like a pencil mark. It doesn't stick to it. It's going to easily fall off. When we want paint, we want it to stick to the surface. And different surfaces require different binders. Paint also has other compounds, like make it more reflective. Often like transition metals are used for this to make it more reflective, glossy, more durable, more resistant to like rain and the environment, even heat sometimes. Paint occurs in layers because you can paint and then paint again if you don't like the original coat. So you can have different layers. And this is very important because if you can relate not just one layer of paint to let's say a suspect, you can get two of them in two different layers, and then that shows a lot more because it's a lot less likely. It's like there's some likelihood that the paint is the same at the crime scene on the suspect, but if the paint is in two layers and in both layers are the same, again, that shows a lot more of a connection. Especially if it's like 3 or 4 layers. Like taking a look at this. This, I think, was the exemplar. That's the one that was the sample taken from the crime scene. This was, I think, on the suspect, actually, no, just the opposite. This, I think, was on the crime scene. This was found in the suspect or removed from the suspect, the exemplar from the suspect, and the layers of paint match pretty well. Now, just let's say one layer of paint would match. Maybe a lot of people have red painted cars. That's not a big deal. But there's a white coating on top of it. So, okay, red, maybe two people that had red paint, and they also coated it with white paint to the similar thickness. But once you get to the third layer, that layer also, it's likely they both have the same source. The paint chip found at the crime scene does come from the same source as the suspect's paint. So how many layers does it take to match it? This is, again, there are professionals who are experienced with this, and they can say how many it would take to form a clear match. But again, you certainly use your common sense. If it's just one or maybe two, that's probably not enough. But 3 or 4, certainly 4, yeah, that's not just random. So we do need to know about the paint that occurs in layers. We need to, and here's some paint chips that were recovered. You don't see the layers, but if you take a microscope and look at the edge, you'd be able to see the layers. Since the main paint evidence comes from automobiles, automobile paints, we really should know about how automobiles are painted. First, we have the electrocoat primer. We put the chassis or whatever the metal parts are. We put it into a tank that has whatever the paint that will bond to it. It's called an electrocoat. You put an electric charge into it, and the electrocoat will plate out onto the surface of the metal. This is a layer of primer which sticks to the metal and will stick to the paint or the next layer of paint that you want to put on it. Not always does, let's say, paint stick directly to metal, but if you put a primer there that sticks to the metal and the paint is designed, or the primer is designed to stick to the paint, and the paint is designed to stick to the primer, so you'll have a good coat of paint on the car. This is what they're done. So the electrocoat, first of all, corrosion resistance, because you're protecting it from the air, and the air will make iron rust. It's uniform over the entire car body, and usually it's dark, gray, or black. That's just the way it is. That's what protects it most, whatever this thing that's colored gray or black, this electroplating, this electrocoat. So that's gray or black. Here it's more like gray than black, but anyway, the point is the next one is the primer surface. That smooths it out. So this it might be uniform, but again, we want to make it smooth so that the coat of paint which follows it will be nice and even, which will make a nice uniform coat, visually uniform coat of paint. So anyway, so this is the primer surfacer over here. If this is, let's say, too dark, and they want to cover up that darkness, so or it's too light, they want to cover it up so that the way the light will get through to the actual coating, which is the base coat, which is the real. That's this layer over here. That's the real coat. That's the real color. You want a red car, that's going to be red. But sometimes the colors behind kind of bleed through, so that's very often the primer surfacer. This thing is made to stop the colors from below from bleeding through. So sometimes it has that kind of a color. Doesn't always, but anyway, the next color, again, the base coat, that is the actual color. You want to have tan, well, your good base coat's going to be tan. And on top of that, you have what they call a clear coat. That's the final coat. It protects the paint. It might be very might have plastic type materials in there, or whatever it has. It protects the paint from being chipped off. Also, it gives it a glossiness, a shininess that sometimes this ordinary paint will not have. So the way to identify it. We need a microscope, of course. It certainly will make it a lot more easy to see, especially if there are tiny paint chips. So the microscope will not only reveal not just the color, but also the surface texture, which is also of importance because the surface texture is the same between, let's say, the crime scene paint and the suspect's paint. Again, that provides a little bit more of a connection. Very important is the layering of paint, as mentioned before. If you can match, let's say, 3 or